That's why I'm a kind of abandoning f of x, okay? Now, you guys know what this looks like, right? Because we've studied it quite a bit. And you kind of know some of what's involved. But today we're going to get more to the story. More to the story. Matter of fact, yesterday I gave you more to the story of a circle. And so I think as a first little exercise here, I'd like to know, can you complete the following? A circle, the definition, is a set of points that are a... Let you continue. Oh, Amanda, you reminded me. A set of points in a plane. I forgot about that. Nice. Otherwise, I'm talking about a what? A sphere, possibly. So a set of points in a plane that are a fixed distance from, okay, some given point. And then I gave these things names because that helps us talk about them. So really, a center is basically all you need to know is what? Try that again. A circle, all you need to know is? So the given point is the center. Bless you. And the fixed distance is the radius. And all the algebra you were doing last night was usually to try and figure out what those things were. So you can sketch a graph. So you can basically know what we need to know about the circle. Okay. Well, I'm telling you that there is a definition kind of like that for a parabola. And I'm going to think about this parabola using this definition. And so let me give it to you. A parabola is a set of points in the plane. Set of all points in the plane. I probably should have said that for both of these definitions. So it's the set of all points in a plane, and then I'm going to use a word that I haven't used before in this class, but I think you can understand. Equidistant, meaning, sure, the same distance, from, and how many things do I have to list after the word from? If I'm saying equidistant, do you understand I'm about to give you two objects? We're going to be the same distant, right? So, matter of fact, Travis is equidistant from Barb and from Jenna. He never thought of that before, but he is, right? You guys follow? Okay, so, well, it's interesting. The vertex is on the parabola, okay? Let me ask you guys this. The center of a circle, is it on the circle? No, it's kind of separate from the circle, right? So the set of all points in a plane equidistant from a given point and a given line. And so I really have to draw a picture of this for you to see what the heck I'm talking about. Okay? And so I want to give you an equation in your book. Oh, first I should give you guys some names. This given point has a name, but it's not going to be called the center. How would you have a center of a parabola anyways? You know? Circle, the word center makes sense. The given point is going to be called the focus. And we'll see why today. And the given line, we will not see why today because I don't know why it's called this. But it's called the directrix. Although I have an idea, I guess. But I don't know. Alright, so I want to show you, well, I like the example that Barb gave us because we're very familiar, or no, as Brittany gave us, y equals x squared. We're very familiar with that one. I can go ahead and graph it. Where's my vertex? 0, 0. So here's 0, 0. Other points on it, please? 1, 1. Okay. Tell you what I'm going to do. I'm going to go really big here. So I'm going to go way out to here and call this 1, 1. And then if I go out to 2, where do I got to go? So let's see, 1, 1 would be right here, I guess. If I input 2, then the output is what? 4, right? Way up here. Wow, okay, so that's 2 comma 4. Maybe this wasn't the best idea, but at least we get an idea of what this is saying. By the way, what happens when you input a half? You get a fourth, don't you? So I want to list that. That when I input, I guess it'd be about right there. When I input 1/2, the output is 1/4. And that's why I wanted to make this a little bigger, is I wanted to include that point today. Okay, 1/2, 1/4. When I square a half, that's a fourth. And by the way, I guess I could list over here the same points. Well, except that I'd have to put a negative sign on the input. So I'd have, right, -1/2, comma 1/4, and I'd have -1, comma 1, etc. Okay? So here's kind of a zoomed-in picture of y equals x squared. If you graph it on the calculator, it looks a lot thinner. You guys follow? Okay. Now, if you turn your book to page, well, let's say 506. Page 506 of this section gives me what they call the standard equation of a vertical parabola. That's what we have here, is a vertical parabola. What I mean by that is, which way does it open? Upward. Or it could open downward. That's the only kind we've ever dealt with before, because those are functions. Could you imagine a parabola that might open a different way? Sure, you could have this kind of a situation. That could be a parabola. Or even a slanted one, which I don't think we'll get to in this class. Okay? But this would be a horizontal. Okay, and we'll do one of those shortly. But I want to do a vertical parabola. Standard equation of a vertical parabola. Okay, well, what do they give me? They give me the following equation. They say it is x minus h quantity squared equals 4p times y minus k where, well, I bet you're going to know what that is. H comma k, any idea what that's going to be? It's the, well, we got to guess. It's either the focus or the vertex, right? But I think you're going to know what it is, because we've dealt with h and k before. Guys, for this example, this one in pink, y equals x squared, right? What's the vertex? 0, 0, right? And notice, what are h and k? 0, 0. And remember that if I were to graph, say, y equals x minus 1 squared, do you know what that would look like? Well, let's think for a minute. What kind of shift is this? Is it vertical or horizontal? Which way? So I'd have the same thing, except where would the vertex be? It would be right here at 1, 0, right? You understand that? So h comma k is in fact going to be the vertex. Okay, now I got to give you a little vocabulary about what this little p represents. And the lowercase p is the, well, the book calls this the focal length. Okay? The focal length. And so I better define that, because that's new words. Man, I told you guys we're going to get technical today. A lot of definitions, things you haven't heard of before. The focal length is not difficult. It's just the distance. This focal length is the distance from the vertex to the focus. That's the focal length. By the way, if it's the distance from the vertex to the focus, I'm going to say it's also the distance from the vertex to what? I'm making you use new vocabulary. To the directrix? I don't know. Does that make sense to you guys? Why would this have to be true? If it's the distance from the vertex to the focus, why does it also have to be the distance from the vertex to the directrix? They have to be the same. How do you know that? In the definition, where was that word? Ah, there it is. Equidistant. Equidistant. All right? So I need to start doing examples to make this all make sense. That's all the definitions I need right now. Okay, there's one more in the book that I'll probably wait on. But I think what we ought to do is take this equation. We had y equals x squared, right? And let's think about that. From now on, when you have y equals x squared, if you want to write it like the book does, how would I write it? I guess I would write x squared equals, well, y, right? That didn't help. What I mean is, what are h and k in this problem? Yeah, so it's x minus 0 squared equals, and then over here I have y minus 0. Oh, that's very interesting, because we're also supposed to have a 4 here, and we're also supposed to have this focal length p here. Does that make sense to you guys? I don't know. Can you tell me what p has to equal for this first example of a parabola that we have? 1/4. That's the only way it'll work. So you get 1/4 times 4. That's right. Do you guys understand? Well, because the equation is y equals x squared, right? And so it's y minus 0 times 4 times whatever p is. So basically, I need this 4 times p. Yeah, I need 4 times p has to equal 1 to get that to work out. So it must be that p equals 1/4. Okay? Now I want to show you how this all works. And then I'll talk a little more. It turns out that the focus of this parabola is going to be a dot right here. That's the focus. And do you know what the coordinates of that point are going to be? Well, I definitely know the x-coordinate. What's the x-coordinate? 0. See, the focus is always going to be on the axis of, do you remember this word? Axis of symmetry, okay? So the focus, maybe we should say that, it's on the axis of symmetry. Well, what I'm going to tell you is that it's the point 0, 1/4. 0, 1/4. Why? Why is it 0, 1/4? Well, because this distance from here to here, that's p. and that's 1/4. We worked that out. The distance from the vertex to the focus. Abby? Boom! As we were discussing in our very enthusiastic discussion, the focal distance of 1/4 is the distance from the focus to the vertex. But it's also the distance from the vertex to the what? What's that other word called? Oh yeah, I didn't draw the directrix yet. Now where's the directrix? Well, it's going to be a line, and it's going to be right below it, and it has to be the same distance away from the vertex that the focus is. And so let me draw that line. If I have a vertical parabola, then I will have a horizontal line for my directrix. And I would love to know, can you guys guess the equation of that directrix? Talk to someone next to you about that for 40 seconds. Very good. Y equals -1/4. Right? I mean, if P is 1/4 and these distances have to be equal, then I think you can get that. Yes, we got technical today. We did a nice job. But we have a reason for doing it, and that is the satellite dish. Well, there's one like that in the book. Actually, they'll talk about a Wi-Fi antenna, which just comes as close as anything. All right, so let's see. That's fine and dandy, but that's the easiest example I could give you, right? Y equals x squared. All right, so let's move on and try another one here in a minute. And if the y is being squared on your parabola, this one is a sideways parabola. 18 times x minus 2. Okay? So, it says it wants me to sketch the graph, and then it wants me to find a few things. Okay? So one of the first things we can do is find the vertex. That one you probably know. Do you guys know what the vertex is? Almost. 2, 4. Right. The x coordinate of the vertex is my h, and the y coordinate of the vertex is my k, and so I know the vertex is 2, 4. And so I guess if I were going to sketch a graph, I'm going to put some graph paper over here on the side, I can say right away, if I put a 2 in for x, the right-hand side is 0, and I put a 4 in for y, the left-hand side is 0. So I can tell you that the vertex of the parabola is right there. Okay? Now I'm curious, I guess, to know any other points on this parabola, right? I need more points to sketch the graph. I'm also curious to know which direction it opens. And I said I knew, but you guys said, well, we're not sure. So let's talk about that. Here, let me do this as an aid to graphing. Let's find intercepts. So for example, the x-intercept. And you might say, well, we haven't done that in a while, but you know what to do. How do you find the x-intercept? We set y equal to 0, because that's going to tell me where exactly it's going to hit this x-axis. All right, let me try that. So if I were to do that, what would this equation look like? I guess it would be, well, 0 minus 4 squared is 18 times x minus 2. This okay so far? So when I square -4, I get 16 equals 18 times x minus 2. You guys with me? I'm going to divide both sides by 18. And so I get x minus 2 on the right-hand side there equals 16/18. I guess I'll call that 8/9. So x equals 2 plus 8/9. x almost equals 3, but not quite. Are you with me on this? Okay. Now, on the picture, where's that? Well, here's 2, almost 3. So it looks to me like the x-intercept would be about right there. Okay? You might say, well, I really don't know very much yet. And you're kind of right. I guess what I know is that the parabola goes through those 2 points. But what happens is, if you understand that this is a y-squared parabola, you understand that it's going to start curving up at that point, because this is my vertex. Okay? That's my vertex. And so this line, you might remember we discovered at one point, this line is called the axis of what? Symmetry. So this is, again, a new object for us. We did parabolas earlier in the year, but they were all y equals x squared. This is more of an x equals y squared kind of situation. Okay? So P, I can find this way. I know that if I have it in the correct form, which I do, okay, so to find focus and directrix, we solve 4p equals what? 18. Okay, it's always that number in front of the part that's not squared. So if 4p equals 18, I guess p equals 18 fourths, which is 9 halves, or 4.5. Okay? So if I have 4.5, now I can do this. I can list the focus and the directrix. Let's see. On the picture, let me move out 4.5. 1, 2, 3, 4.5. Right there. So now I can label the focus. And the focus is a point. Well, I know the y-coordinate. What's the y-coordinate? Has to be the same as the vertex y-coordinate, so it has to be 4. Does that make sense to people? But now the x-coordinate, well, it used to be 2, but I'm adding another 4.5. You guys see that? So what's the x-coordinate going to be? 6.5, comma 4. Maybe the book would put 13 halves. I don't know. I didn't look at their answer. So far, so good? Okay. Now, the directrix is going to be a line if we go back 4.5 in the other direction. 1, 2, 3, 4.5. This line here is the directrix. Okay? So I might ask again, what's the equation? Well, it's going to be, because this is a vertical line, the equation is x equals something. Now let's see, what's it going to be? Looks to me like it's negative 2.5, because I went back 4.5 from 2. Does this make sense? Okay. It's kind of just working slowly, I think, that gets you this stuff. Okay, anything else they want? Oh, the endpoints of the lattice rectum. What's that? So, go ahead, what? That's right. See, if you drew it kind of tells you how wide this parabola is going to be. And the nice thing about putting it in this form, okay, is that you have the lattice rectum also. Okay? This 4p is the length of the lattice rectum. So this 18, in other words, shows up on my picture. That 18 is the length of this segment. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see that? And if I went up 9, which I can't or I'll be off the map, I guess it'd be up here, right? But what this tells me is kind of where the parabola goes. It shows you my sketch was off a little bit. Let me fix my sketch. It goes through the x-intercept that I showed you, but then it also has to go through this point, the end point of the lattice rectum. So there you go, right? Again, this length is called the lattice rectum. And it's length for P, which is 18 in this case. And they always put absolute values for length has to be positive. Do number 12 here. 2y squared plus 4y plus x minus 8 equals 0. And I'm going to go ahead and use graph paper. Okay. So let's see. 2y squared. Plus 4y plus x minus 8 equals 0. So the idea is we want to push everything to the right-hand side except for the part that we're going to complete the square. I think this is why Stitch does this. I understand. 2y squared plus 4y is now equal to, well, I guess we'd have to write negative x. I want to put the x's over on the other side. And then I'd have to write what? Plus 8, right. Okay. Now, let me show you the next step that I think is kind of important here. We're in good shape if we make the coefficient 1. Equal to 1. So let's see, how would I do that? Sure, just divide. You can factor also, but I'm going to divide both sides by that number, and that'll do the same thing, right? If I divide, what do I get? Well, I get y squared plus 2y equals, what's over here now? Negative 1/2 x plus 4. Oh, and I should have done something. I should have made room right here, right? Because here is where I need to complete the square. How do I do that? Half of what squared? Right. This one's a simple example. But that's okay. Just for the sake of time, it's good to have something we can actually do. So I need a 1 squared, which is plus 1. I need to add 1 to both sides. Does this make sense, people? So I'm going to add 1 over here, and I'm going to add 1 over here. This okay? Mm-hmm. So now what do we have? Y squared plus 2y plus 1, that is a perfect square. What does it equal? Y plus 1 squared, right? Y plus 1 times y plus 1 is y plus 1 squared. Equals, and here we have negative 1/2 x plus 5. That's okay? So now what? Am I done? Remember what the actual form of this equation is. We'd like to get it to say, I guess it would be y minus what? H or k? K goes with y, because k is the y coordinate. So it's going to be y minus k squared. squared equals what? 4p times, we want x minus h. So I'm trying to get it to look like that, guys. Do I have that? I guess I'm getting there, right? I know what k is. What's k? Good try. It's -1, right? K is -1. I'd like to get this to look like that, so I have to do a factoring thing here. I need to do some GCF kind of work. I'm going to write y plus 1 squared equals, do you know what I'm going to factor out? -1/2. And here I have to be careful because of the fractions. So actually, this was a good example to pick. -1/2, and what will I write next? X, and you got to be careful, minus what? 1/2 times what is 5? It's actually 10. Does that make sense to people? You can always check your work, right? When you factor, you check your work by multiplying it back out. It does work. Okay. So I think we're in pretty good shape here. Now let's see. What would I want to do first? Well, if I'm going to plot the graph, let's see. I'll get some graph paper out here, and I want to sketch a picture. I'll put it right here because I don't know where this thing's going to go yet. I guess what I want to do is I want to plot the vertex, right? So what is the vertex? The vertex is, 10 is the h, comma, -1. So my vertex is 10, -1. Let me plot that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -1. So there's my vertex, 10, -1. Oh, I guess the next thing is, which way does this parabola open? Why to the left? So you're hoping it opens left, right? And you're correct. That's actually why I kind of put it there. But there's another reason it... First of all, does everyone understand this is a horizontal parabola? Because it's of the form x equals y squared. That means it's going to go left or right. Now, how do you know it opens left? Well, that's because this coefficient right here is negative. See that? That's telling me left. Because to the left is negative and to the right is positive, just like up and down. Okay? All right, one thing left to do, and that is I'd really like to know what p is. So again, 4p is always the coefficient. So I guess the equation that I have is that 4p is equal, bless you, to -1/2. Right? So what does p equal? Ooh, what does it equal? Well, I guess it equals -1/8. By the way, the fact that p is negative tells you where the focus is going to be. The focus is going to be to the left. So it's funny because the vertex here is 10, -1. Right? That's the vertex. The focus is going to be only 1/8 to the left. So that focus, okay, would be, well, I guess it would be 9 7/8, comma, -1. Does that make sense to you guys? It's 1/8 to the left. What about the directrix? Okay, let's plot it. So this is going to be very close to each other. Okay? And so that's going to be x equals, what would it be? I guess it would be whatever 10 1/8 is, right? 10 1/8. There's one thing in the book they'll ask for that I did not define. It's called the latus rectum. Students always think that's really funny. Well, it's not. But it's just kind of a horizontal distance. See, what happens is, the only other thing you want to know is how wide this is. This is going to be a wider parabola than the one before. Okay? But basically, the latus rectum, maybe I should show you that on the previous example. It's the distance through the focus to either point. So in this example, it was 1/2. And the length of the latus rectum is always 2 times p. You'll see that in the book. All right, we are done today. Have fun with the homework, and I'll see you tomorrow. All right, so it says that my focus is at 0, 0. And it says that my vertex of the parabola, 3, 4, 5, 6, 7, is right here, right? This is the vertex. This is the focus. So which way does it open? Which way? To the left, all right? So that's important to understand. Oh, actually, don't have room. My directrix, I told you guys to draw it, right? It would be 7 more places over here. I guess it would be out here, right? The directrix would be x equals 14 for this one. You guys with me? Okay. So one of the reasons that you need to draw a sketch is you have to figure out which form of the parabola to write down. See that form up here on the board? That's not the correct one. Okay? It's going to be, so I guess from the picture, I can tell already that the picture, since it's opening left, okay, I can tell it's going to open up to the left, right? So I can get the correct form. It's going to be y minus k squared equals, okay, let me write down 4p times x minus h. It has to be a y squared one because it's opening left to the left, not up or down. Does that make sense to people? It'll be y minus k squared. Yes. The y is being squared in a sideways parabola. The x is being squared in the more traditional function parabola, right? This thing I'm going to graph is not going to be a function of x. I guess it'll be a function of y. But okay. So now what? Oh, one more thing I'll say. If I put this little negative sign here, does that make sense to people? I mean, the reason I'm writing a negative is because it's opening which way? To the left. Just like in the old parabolas, we knew that when it was a negative, it would open downward. Okay, this is the same deal. Okay, so let's see what we could fill in now. Well, we could fill in the vertex, right? Since the vertex is 7, 0, what can I say? Instead of writing y minus k squared, what could we write? Sure, y minus, oh wait a minute, y minus 0 squared is equal to whatever negative 4p is times x minus 7. Is this okay? Yeah, so I'm going to get y squared equals, really there's only one thing left to fill in, and what is it? P. Now how are we going to get that? Well, I know something. I know that 4 times p has to equal what? Well, the focal length. In other words, the length from the focus to the vertex. So 4p equals what in this problem? 7. So p is equal to 7/4, and so I get, let's see, y squared equals negative 4. Well, why even do it that way? Once I know that 4p is equal to 7, where it used to say 4p, what can I write? 7. Negative 7 hang on a second, that's not right. Correction. The focal length is p, not 4p. Since the focal length is p, which is 7 in this case, what I need is negative 4p, which is negative 4 times 7. There we go. Negative 28. Much better. Sorry about that. I was like, that's not right. So let me rewrite it, the correct answer down below. Y squared is negative 28 times x minus 7. That looks better. Make sure that's what they have. Yeah. Okay. You got that? Now you guys also asked about 17. I'm not sure what the difference is. Oh, okay. Because they don't, this is tough, number 17. In 17, they don't give you the same stuff. Let me show you what they do give us. Okay, so for 17, they tell me the vertex is negative 8, negative 9. All right, I'm going to need new graph paper. Go ahead and use it. So for 17, draw a nice big piece of graph paper. Okay, so they tell me that the vertex is negative 8, 3, 4, 5, 6, 7, 8, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is my vertex. Okay. Then they tell me that 0, 0, and negative 16, 0 are points on the curve. So here's the point 0, 0. And then they say, oh, shoot, way out there, I ran out of room, negative 16, 0. Those are points on the curve. All right, so here's the game. One of the first things you have to try and figure out is which way does this parabola open? So let me have you talk to your neighbor about that for 20 seconds. This one has to open, which way? Up, has to, right? Because the vertex is somehow the extreme point. And so, yeah, I can see that, somehow this is going to go that way towards 0, 0, and it's going to go that way towards negative 16, 0. And so the axis of symmetry would be, I guess, x equals negative 8, right? So the vertex is on that line. The focus and directrix are also going to be on that line. Now, what I know so far is I know what form to use, okay? What do we want to square for this parabola? We want to square the x, right? So we're going to write x minus h squared is 4p times y minus k squared. Do you think I'm going to want a positive or a negative for this 4p thing? Positive because it's opening up. If it was opening downward, we'd make it negative. All right, and let's fill in what we can. So we want x minus, well, h, that's negative 8, right, squared. Of course, I'm going to rewrite that in a second. What am I going to write? We're going to write x plus 8, and similarly, we're going to write y plus 9. Oh, wait a minute. There's an error. Do you see my mistake? Don't square this guy. If you square both of them, it's not a parabola anymore. Only square one of them. Okay. So I'm almost done. I just have to figure out p here, that length. So right now I have this. I have x plus 8 quantity squared is equal to 4p times y plus 9. Okay? And this is actually a great problem to do today because it kind of ties into where we're headed. We want to know what p is, right? What's that? You say, I know what p is? How? You say the focus is right here? How do you know? Yes. But how do you know that the latus rectum isn't here? Or here? Or up here somewhere? Well, aren't these different numbers? These lengths are all different, right? Well, that's a good question. How are we supposed to figure it out? Okay? I guess maybe you're right. And if this is the latus rectum, then I think he kind of made it a little easier than it had to be. All right? So it did work. All right, that's interesting. But I'm telling you, it's kind of a coincidence. Okay? What you could do is this, though. See, when I know 0, 0 is a point on the parabola, what that means is if I plug 0 in to the final answer, it works. That's how you checked, right, Barb? When you said it worked, or did you check from the answer key? You look at the answer key, you know it works too. But you could check your answer because 0, 0 has to work in the equation. And by the way, so does negative 16, 0 has to work in the equation. So what do I mean by work in the equation? I mean, hey, where it used to say x, what am I going to write? 0, right? So let's plug in a 0 here and a 0 here for the y and see what we have now. 0 plus 8 squared is equal to 4 times p times 0 plus 9. Okay? Well, now there's only one unknown, and that's the p. So you could actually solve. You get 64 is, well, 9 times 4 is 36p. This okay? So what does this mean? This means p equals, well, 64 divided by 36. I guess I could simplify that and get p equals, if I divide top and bottom by 4, I get 16 ninths. So that's my focal length, 16 ninths. Okay, so what's that mean? That means my focus is going to be 16 ninths higher than this vertex. 16 ninths, how big is that? 16 eighths would be 2, so this is a little less than 2. So I'm getting that the focus is here, and the directrix is down here. And that means, by the way, my latus rectum is right here. Okay. But that still doesn't give me the final equation. Well, it almost does, right? The final equation, I was up to here so far. The only thing I didn't have was p, but now I know what p is. So we can write x plus 8 squared is 4 times 16 ninths times y plus 9. And so I guess my final answer is going to be x plus 8 squared is 64 ninths times y plus 9. Those are good problems to try.